Somewhere in a railway archive, there is a general arrangement drawing with a single number written on it, and that number has nothing on either side of it. Locomotives are almost never built alone. A railroad orders 40 of them, or 300, because the entire point of a locomotive is that the next one is identical. Same spare parts on the shelf, same faults in the same places, same crews who already know, in the dark, where every valve is. So when you find a locomotive that exists exactly once, you are looking at a verdict. Somebody spent years and a fortune, rolled it out into daylight, watched it work, and then decided never to do it again. And in most of these cases, the thing that killed the machine was not bad engineering. Several of them were the most advanced objects on any railway in the world on the day they entered service. Something else got them. These are 10 locomotives that never got past a single prototype. Number 10. The engine that was steam and diesel at the same moment. In the mid-1920s, a locomotive works in Leeds bet its future on an idea that sounds like a riddle. A steam engine pulls magnificently from a dead stop. A diesel engine is far more efficient once it is running, but makes almost no torque at zero speed. So why not build one engine that is both? Not two engines bolted together in one frame. One engine. Inside every cylinder sat a double-acting piston with diesel combustion happening on one face of it and steam pushing on the other. You started on steam. Once the wheels were turning, fuel was injected into the diesel side and combustion took over, and the waste heat coming off that combustion boiled the water that made the steam. The machine spent years on trial in the north of England, working ordinary freight turns out of York, hauling real tonnage for a real railway. Fuel consumption was genuinely impressive. What beat it was arithmetic that no engineer could redesign. The whole case for the locomotive rested on oil being cheap compared with coal, and in Britain in the early 1930s it was not. Meanwhile, a decade of development had bled the builder white. The company called in the receivers in 1934, and its one locomotive went back to Leeds to be broken up by the firm it had helped bankrupt. A good machine, killed by a price ratio. The next one was killed by something far more ordinary. A room full of buyers who simply were not interested. Number 9. The salesman that nobody bought. In 1926, a Philadelphia builder rolled out its 60,000th locomotive and numbered it accordingly. Nobody had ordered it. The company built it at its own expense as a rolling argument about where steam power ought to go next. The argument was pressure. Conventional boilers ran at around 200 pounds per square inch. This one ran at 350, using a firebox built from water tubes rather than flat plates held together by thousands of stays. 3 cylinders, arranged so the steam did its work twice. High pressure in the center cylinder, then exhausted into the 2 outside cylinders to be used all over again. Then they took it on tour. Over roughly 2 years, the locomotive ran 100,000 miles across other people's railroads. On a stationary test plant, it produced over 4,500 horsepower, the highest figure that plant had ever recorded. And not one railroad ordered a copy. The reasons were mundane. It was heavy and it was long, and a great many main lines could not take it. Mechanical departments looked at that water tube firebox and saw a maintenance bill. So the demonstrator went home, spent a while as a stationary boiler at the works, and in 1933 was handed to a science museum in Philadelphia for a nominal $1. It is still there, which makes it, out of everything on this list, the lucky one. Number 8. 500 pounds of pressure and 4 cylinders in 4 corners. At almost the same moment, a coal-hauling railroad in the Northeast was running its own campaign against low-pressure steam, driven personally by the man in the president's office. 3 high-pressure locomotives had already come out of the program. In 1933, the 4th and strangest entered service, carrying the president's own name on its flank. The layout was unlike anything else in America. 4 cylinders, 1 at each corner of the machine. Steam left the boiler at 500 pounds per square inch and went first to a single high-pressure cylinder tucked under one side of the cab. Its exhaust went to an intermediate cylinder on the other side, and that exhaust fed 2 big low-pressure cylinders at the front. 3 stages of expansion, each one wringing out what the last had left. On paper, it was thermodynamically superb. In a locomotive shed, it was a nightmare. Its valves were rotary cam operated rather than the arrangement every fitter in the country had grown up with. And it could only really be maintained by the men at the one shop that had built it. Take it away from those people, and small faults became long delays. The president who championed it stepped down in 1938, the high-pressure program ended with him, and the locomotive was quietly cut up. Its railroad went back to ordering conventional engines and never experimented like that again. Engineers on the other side of the Atlantic had been watching those high-pressure experiments closely. They took the idea further, and they did it in secret. Number 7. The locomotive built behind screens. In 1924, the chief mechanical engineer of a large British railway went to a Glasgow shipyard that built boilers for warships and asked whether a marine water tube boiler could be squeezed into the width of a locomotive. The answer took 5 years. It was assembled at a works in the northeast of England behind hoardings, with staff forbidden from discussing it, and the railway press gave the thing a nickname that stuck for life: the Hush Hush. It emerged in December 1929 with 4 cylinders working compound, a boiler press to 450 pounds per square inch, a tall slab-sided casing punctuated with little portholes, and a 5-digit running number, because there was nothing else in the fleet to number it alongside. It also leaked, constantly. A water tube boiler is a marvel in a ship's engine room, where a specialist crew looks after it. In a working locomotive shed, surrounded by coal dust and men with a night's worth of engines to prepare, it was an unrelenting nuisance. The numbers tell the story better than any anecdote. In roughly 1,900 days between construction and withdrawal, this locomotive spent more than 1,100 of them inside the works. Well over half its life was spent being repaired. In 1937, it was rebuilt with an ordinary boiler and a streamlined casing, becoming a fairly conventional express engine that ran until the end of the 50s. The experimental boiler was pulled out and put to work heating the workshops. It outlasted the locomotive it was built for. Number 6. 8 cylinders and no connecting rods on the outside. In 1941, a builder in central Germany delivered a streamlined express locomotive that abandoned one of the oldest assumptions in steam engineering. Instead of large cylinders driving one axle through long rods, with all the hammering that arrangement puts into the track, each of the 4 driving axles got its own small 2-cylinder steam motor. 8 cylinders in total, tucked away underneath. It was borrowed logic. Electric locomotives had been driving each axle individually for years and rode beautifully because of it. It worked. On test, the machine ran at speeds approaching 180 kilometers an hour, and the ride was in a different class from anything with rods flailing outside the frames. But in 1941, Germany was pouring everything into the war. Precision machinery in 8 small cylinders was exactly what a wartime railway could not maintain. The prototype was damaged in an air raid on Hamburg in late 1944 and sat out the rest of the conflict. Then came the strangest afterlife of any locomotive here. Repaired by its builder, shipped across the Atlantic in October 1945, and tested by the United States Army in Virginia, where its speed was confirmed all over again. It was scrapped there in 1952. The most sophisticated steam locomotive Germany ever built died in a field on another continent, examined by people who no longer had any use for steam at all. Number 5. The locomotive with no pistons. By the early 1940s, an American railroad that hauled more coal than anyone else in the country was watching diesels arrive and wanted a coal-burning answer. What arrived in late 1944 had no cylinders and no main rods at all. Steam went straight into a turbine, and the turbine drove the wheels through reduction gearing. A separate, smaller turbine handled reverse. Turbines love steady, high-speed rotation. Above about 40 miles an hour, this locomotive was extraordinary, smooth as a ship, capable of outpulling contemporary diesel sets and running well past 100 miles an hour. Crews called it the Big Whoosh, because that is what it sounded like leaving a station. The catch was the other end of the speed range. Below 40, the turbine was hopelessly out of its efficiency band and drank steam faster than the boiler could make it. There was no way to gear around the problem because there was no gearbox, only a fixed ratio. It ran for about 4 years and made its last trip in June 1949. Plans for a bigger successor were drawn up and abandoned, and the one built example was cut up in 1952. Number 4. The one where the fireman was sealed inside. Its designer looked at steam power in 1940s Britain and concluded that the real problems were not thermodynamic. They were practical. Crews worked on an open footplate in filthy weather. Engines had a front and a back and had to be turned, so he designed a locomotive that looked like a diesel. A full body shell, a driving cab at each end so it never needed turning, 6 cylinders with sleeve valves, and chain drive through 2 power bogies. The whole thing could be run through a carriage washing plant. 5 were ordered, 1 was finished. The fireman was placed in a compartment in the middle of the body, between the driving cabs, sealed in beside the firebox. In an open cab, moving air carries heat away. In a closed box, it does not. Firing that locomotive was punishing work in a confined space, and it needed a second man just to bring coal forward. The mechanical troubles came in waves. Sleeve valves broke repeatedly. A crank axle failed. The fire brick lining kept collapsing into the fire, and the thicker replacement brickwork ate into the heating surface. And then, right at the end, after a full overhaul of the valves and rings, it ran beautifully. On its final outing in November 1950, it took 15 coaches uphill at an easy 50 miles an hour and touched 90 on the way home, riding as smoothly as a passenger car. 4 months later, the project was canceled. All 5 machines, including one that was almost complete, went for scrap. If you are enjoying these, take a second and subscribe. We put out a new railway engineering story every week. Number 3. The gas turbine found under a dust sheet. In 1961, a British electrical manufacturer completed a locomotive at its own expense to prove a point about gas turbines. From the line side, it looked absurdly conventional. A tender behind it, the silhouette of an express steam engine. But there was no boiler. Inside sat a 2,700 horsepower gas turbine driving the center axle through a gearbox, and the tender carried kerosene. On long, sustained climbs over the northern hills, where a turbine can settle into its efficient range and stay there, the machine performed very well indeed. And that is where the story stops, for a reason that has nothing to do with the turbine. By the early 60s, Britain had committed to diesel electrics with a cab at each end, turned around at a terminus by the driver simply walking the length of the machine. This locomotive had 1 cab and a tender behind it. It would have needed turntables. In a country ripping turntables out, nobody wanted to say no formally, so at the end of 1962, it was returned to the works and covered with sheeting in a corner of the shop. It stayed there 4 years, until a journalist on a factory visit noticed the shape under the covers and published the story. In February 1966, the remains were towed to a scrapyard. The locomotive that pulled it there was a steam engine. Number 2. Coal's last stand. 2 American railroads owned enormous coal reserves and had every commercial reason to want a locomotive that burned the product they were already digging out of the ground. In May 1954, the more stubborn of the 2 took delivery of the machine meant to settle the question. Forget everything a steam locomotive looks like. This was 161 feet long, with its tender weighed close to 1.2 million pounds and rode on 4 6-wheel powered trucks. A water tube boiler fed a turbine. The turbine spun a generator, and the generator fed traction motors on every single axle. 4,500 horsepower with automatic firing controls. On paper, a coal-fired diesel. Crews named it after the folk hero who outdrilled a steam drill and dropped dead at the finish. Nobody seems to have thought that through. At low speed, it developed enormous tractive effort, and it spent much of its short career shoving heavy coal trains up a mountain grade in Virginia, the one job that suited it perfectly. But the fault was structural. This machine carried every complication of a steam locomotive plus every complication of a diesel electric, with a turbine on top. Coal dust and water found their way into the traction motors. Every hour it spent in a shop was an hour a diesel was earning money. It was struck off the roster on the 4th of January 1958 and scrapped that year. The railroad that built the last mainline steam locomotives in America had already started buying diesels. Number 1. The best steam locomotive ever built, and nobody wanted it. In 1932, a French railway took delivery of a large express locomotive that turned out to be a disappointment. It was heavy, thirsty, and unremarkable. It shuffled between depots, doing very little of consequence for the better part of a decade. Then France's greatest steam engineer got hold of it. He had spent his career proving something most designers never grasped, that the limit on a steam locomotive was rarely the fire or the cylinders, but the passages in between. Steam has to get from the boiler to the cylinders and out again through the chimney, and every sharp corner, every restriction, every badly shaped port costs power. Fix the flow, and the same boiler makes far more. He rebuilt the disappointment completely. An extra axle to carry a bigger firebox, siphons to circulate water, compound expansion with one high-pressure cylinder feeding two low-pressure ones, and an exhaust arrangement of his own design. It re-entered service in 1946. What came back was arguably the finest steam locomotive ever to turn a wheel. It sustained power figures no French steam engine had approached, on noticeably less coal and dramatically less water than comparable machines elsewhere. From a standing start, it could take a train of over 600 tons to 60 miles an hour in about 3 minutes. It should have been the prototype for an entire post-war fleet. Its designer had already drawn the family of engines meant to follow. None of them were built. France had decided its future was electric, and the National Railway was not interested in a steam locomotive whose test results made the comparison awkward. The prototype was sent to a depot in western France and worked express trains for a decade in near anonymity. In 1960, it was withdrawn and quietly scrapped. Not preserved, not displayed. Nobody wanted a monument to the argument they had chosen not to have. Look back along these 10, and the pattern has almost nothing to do with metallurgy. The hybrid lost to fuel prices. The demonstrator lost to axle loads and habit. The high-pressure freight engine lost to the men who had to maintain it. The German machine lost to a war economy. The turbine lost to the speeds it actually worked at. The one with the sealed cab lost to a committee 4 months after it finally ran properly. The gas turbine lost to the shape of a cab door, and the best of all of them lost to a decision made before it ever moved. A prototype is not really a test of a machine. It is a test of whether an organization will reorganize itself around a machine, and organizations almost never will. Being better is not enough. You have to be better in a way that costs nobody anything, and no genuinely new idea has ever managed that. The next time you see a preserved locomotive with a plate on the smoke box and a number on the cab, look for the numbers on either side of it. If they exist, you are looking at a survivor of a fleet. If they do not, you are looking at something rarer. A finished argument. A machine that convinced its engineers completely and convinced its industry not at all, standing there for the rest of time as the only evidence that anybody ever tried.